So we're going to talk about function notation for Algebra 2, and it's similar to the one I do for Algebra 1, but it gets a little more in depth, and it looks at some different types of functions that we don't really focus on too much on the Common Core Algebra 1. So I'm going to kind of skip through some of the examples and do parts. So just kind of, if I don't do one, don't worry about completing it yourself. I want you to focus on the questions on the second page when you get to it. So the whole idea of function notation, kind of circled it there. You get some x value, apply some rule to it, and then you get an answer out. So any equation where you get an answer out after putting a number in, that's an example of a function. So if we take the first one here, they say f of 3, and they give us f of the rule up here. All you're doing is you're taking the x out, and you're putting in the number 3. Then you would take this part right here, and you just go ahead and you type it in the calculator. And probably a lot of you can do it in your head. But if I go ahead and I do 5, parenthesis 3, minus 2. So that's my answer. And again, the idea here is that the answer is 13. So I want to write it down and kind of box it in. But what this corresponds with is a point on the graph. So if you take 3, 13, that x and y value together make a point that's on that table for that graph. If you do the next one, they want us to put 3 in for x, so it's got a square with it, so we're going to still include the square outside. Okay, and this one, coincidentally, ends up being 13 as well. And then again, it's just, like I said, parenthesis 3. You want to make sure they look alike as you're putting them in. And then for the last one, you got 3 again, they want us to put in, and this one is just 2, and then the exponent's 3. So that one will be 2. Caret symbol, get our exponent, and then we're going to have 8. So this goes through some of the first ones that we're doing. Just taking input values, putting them into the equation, and then getting an answer out. So if we move on, a big thing with functions is that there's different representations of functions. So you have equations, which we talked about, and then you have graphs and tables. So this one gives us a table. Now, one of the things I've been focusing on with my Algebra 1 students is making sure they actually read the question and underline what the letters represent. So it says right here that the temperature is T, and then H is the number of hours. So I want you to get in the habit of doing this and underlining that in the question, because now it actually gives us some application of what we're talking about. So like if you take a look at part A, it says T of 2. Well, what does 2 mean? Okay, we just talked about it. T of H is the function, so 2 represents hours. So they're asking us the temperature at 2 hours. And in the case of the table, you can clearly see from what I circled that it's going to be 104 degrees Fahrenheit. Now I can include my measurement. I know what it's talking about. And then the same thing with 6. I'm not going to write it in there, but again, 6 is 68. Now they can figure out also backwards, you can find out by which value of H, hours, gives you 76. Well, you can find that value in the table as well. So sometimes people think the tables are the easiest. And then for C, what 2 consecutive hours is the temperature 100? Well, it's going to happen somewhere between 2 and 3. Okay, so I'm not going to write all those down. I'm just going to go through it quickly, but now we're going to go ahead and take a look at the third representation. Sometimes they might just give you a graph. And a lot of students think, well, what am I putting in the graphing calculator? Well, it'll tell you in the question if they want you to graph something or not. And this one, they tell us clearly, answer the following questions based on the graph. So you're only using the graph. You're not going to be putting anything into the calculator because they already give you what you need. Now for each of these, what we're going to do is we're going to take each of those x values and we're going to look at the table and figure out when, by movement of up or down, what the answer is out, the output value based on that input. So if we have f of -1, -1 will be 1 to the left of the y-axis. And in that case, it touches it the line right on that x-axis. So that means that says 0 is the answer. And for 1, f of 1, if I go 1 to the right, then I got to go 1, 2, 3, 4 up. 4 is going to be my answer. And then for 5, well, I go 1, 2, 3, 4, 5 to the right. And then I got to go down. So I go down 1, 2, 3, 4. And if I go down, I got to include the negative. So for part B, it says evaluate f of 0. Well, same way we did the other ones, except you don't have to move from the y-axis. And in this case, we got to go up, get an answer of 3. And they say, what does this special feature correspond to? Well, it's on the y-axis, so that means that it's also the y-intercept. Okay. Now for part C, they refer to zeros. So when does the graph equal 0? So if you go on, and I'll do this one in green. If you go on the graph, everywhere your graph touches the x-axis represents a 0. So the x values when that happens, x equals -1. It also equals 0 at 3, and it also equals 0 at 7. So we have 3 zeros in that case. And then we're going to just move on to exercise number 4. We're going to skip over D for right now. Now this one asks for, or gives us a graph. They don't give us an equation, so we can't actually graph anything. But what they do ask is, it is known that this. So they want us to ask what following point must lie on the line. Well, we know that this is the input value, so that's our x value. And then the answer out's the y value. So that one's not too hard. It's just going to be -2, 7. Now for the last one, again, we have a question modeling. So first thing I'm going to do right now, we got a physics student drop a ball from the top of a 50-foot high building. Okay. So it's got height as a function of time. So we have height, and in this case, looks like height's measured in feet, based on what they tell us. And then time, like it says, is going to be measured in seconds. So they want us to figure out to the nearest tenth when the ball hits the ground. So what we're going to have to do first is we're going to have to switch this table around on the calculator. So if you go to second and then window, you get the table set. Now we want to start our table at 0, and they want us to go by tenths. So we're going to end up putting in 0.1 as our change for our table. Next thing I'm going to do is I'm going to go and try to graph the question. So I got 50 minus 16, got to put x in, not t, and squared. And then I'm going to go look at the table, because it says to get my information from the table. So they want us to figure out when it's going to hit the ground. Well, if it hits the ground, that means it's at 0 feet. So we got to find the number where we're closest to 0. So there's no easy way to do it after you switch it. You just got to kind of go through. Okay. So it looks like right here, in this part of my graph, between 1.7 and 1.8, it looks like that's the part where we cross through 0. And in the case of to the nearest tenth, which one's closer, this one's going to have to be, for time, 1.8. Because if you can see my table, 1.7 is over 3, but 1.8 is within 2. So t is 1.8, and then you would just write down some of this in this part right here. That would kind of be your work, because it says to provide outputs in the table to support the answer. So as you're working through the assignment, as you're looking at the questions on the assignment, you will pretty much do every question on this assignment. And again, just be careful, because on some of the questions, like question 5, they do give you specific intervals they want you to use. So when you use the graph, you're not going to just necessarily count it by ones. You're going to have to, like it says, scale the y-axis properly. Okay?